This starts our Unit 2, Molecules and Compounds.
And this will be lecture 2.1 here.
All right, so a little review here on our electrons. Electrons can fit in each level differently. So our first level, we have 2 electrons can fit in it. Our second level, 8. Third, 8. And our fourth, 18. Remember, 2, 8, 8, 18. Say that on repeat to yourself, so that could help you. Valence electrons, that valence is, they are the outermost electrons on their energy level. They are important for chemical bonding and stability of those atoms. And then we also have the octet rule. Atoms gain and lose or share electrons to have a full valence shell of 8 valence electrons.
So just again, reiterations, this is all stuff from our first unit, as well as stuff you should know from before this class. When we are talking about bonds, and that's what we're going to be looking at in this unit, various compounds and how they form bonds, it is the valence only, those electrons in the outermost energy level that we are concerned with. All the others are a non-issue. So we're always going to be looking for valence number because all those atoms are looking for that octet rule completion, that 8 VE in that outermost.
All right, so a little bit review about our periodic table and those clues. The rows are called periods, so they correspond to the number of energy levels used by each electron, or used by the electrons. So that is going from your left to right. Rows are going across. You should have that labeled on your periodic table, probably 1 EL, 2 EL, and so on. Columns are the ones that go up and down. Those hold up our houses and buildings. Those are called groups and families. They correspond to the number of valence electrons, sort of. So remember the exceptions and use this to help you figure out the ion charges as well.
So remember in our first unit, we talked about when Ms. Case was having you label it on your PDF copy and annotate, we looked at the tall columns, right? That's groups 1 and 2. And then we skip over our transition metals because they're short stacks, and we go to group 13. So groups 1, 2, and then starting at 13 all the way to 18. Those are our groups that are going to indicate their ion charges based on their group numbers. So 1 is going to be +1. Group 2 is going to be +2. We skip to 13. Remember, it ends in a 3, so that's going to be +3. Our 4 is going to be either or. And then when we get to group 5, that's when we start going down, right? We become negative. So -3 with group 15, -2 with group 16, and -1 with group 17. Again, all things you should already have labeled on your periodic tables.
All right, and then our cations and anions on the periodic table. Metals, the majority of the elements on the periodic table form cations. So those are your positive charge or your positive ions. We like to say that there is a T in cation, so that T is representing a plus sign. Okay, those are on the left side and the bottom. And then we have our nonmetals that form anions. So those are your negative charges. Those are on the right side of the staircase. Then we also have metalloids or semimetals. Those have properties of both metals and nonmetals, and those are on the staircase.
So again, Ms. Case's clues. Cations with the T means it's a positive ion. What does a positive ion mean? That means that we have more positive charges left in the atom than we do negative. So that means that element gave away negative charges. It moved electrons away. If we are an anion, that means that we gained negative charges. So electrons were brought to the atom, resulting in more negative charges than positive charges. And those two types of ions correspond to the type of element that it is. Metals are going to form positive ions, and nonmetals are going to form those anions or those negatives. And you use that staircase in your periodic table to help you. Those semimetals, basically what that means is they're kind of in between. In other words, they sometimes have properties of metals and sometimes have properties of nonmetals. And that's because they're on that border. And so they're very interesting and unique. Miss Case has, Miss Case, the link that's at the top, Miss Case, I know reminded you in the beginning of the year that those asterisks mean something. You would have noticed one on the previous slide too, that would take you to a video about the periodic table in general. This one is going to take you to a copy of the periodic table. And I believe we've got that interactive periodic table on your unit page as well. But you can always click through those links in the slides too, to give you that information.
All right, and then representing valence electrons using the dot diagram. This is one of my favorites things to do, is using dot diagrams. So when we are utilizing dot diagrams, the first thing we are going to do is write the symbol in the center. As you can see down there on the left, on the bottom right, we've got two elements there. So Na, that would be one of the symbols, right? Capital letter and then a lowercase following it for sodium. Then you're going to determine how many valence electrons that element has. So in the case of sodium, Na, it is in that first column, so it has one valence electron. You're going to draw the first dot on any side and then add one dot at a time on each side until you have paired them up. Only 2 dots per side and a maximum of 8 dots total. So because sodium only has one valence electron, it's only going to get 1 dot. If you take a look at chlorine, which is a great one too, that is in group 17 there. So again, your columns are going up and down, 17. So that means it's got 7 valence electrons. So it should have 7 dots around it for our dot diagram. When you draw that, you draw 1 dot at a time. So I always start at the top and work myself clockwise. So 1 on top, 1 on the right, 1 on the bottom, 1 on the left, and then pair them up.
The purpose of the dot diagram is to provide us with a shorthand way to see the valence electrons. And this is something we'll be doing in practice and with our Jamboard so that you can get practice with it. And what it allows us to see is availability of electrons that can be given away. Sodium wants to give that one away, right? And just so happens chlorine is looking for one. And so this allows us to see that relationship, and this tells us how we're going to form ionic bonds and have chemical reactions.